Questions before we get started? Thank you, by the way. Questions about anything you've been working on?
We're going to go over the 8.3.
Yeah, so I'll go over the solutions to the equations that I handed out last week, and then I'm going to show you some applications to some of these equations. And then after Chapter 8, the idea of Chapter 8 is we want to get really proficient at solving equations. Then Chapter 9 is really all about constructing and applying equations. So, okay, so let's practice some. We'll start from the top here. So this is a equation with fractions in it. What's the strategy when you have fractions inside of equations? What do you think? You guys remember?
Clear the fractions.
Yeah, we want to clear the fractions out because it's just going to make our life a lot easier. And the way you do that is by giving everything the LCD, right? So the least common denominator here is 4. Do that. And then, so we're going to distribute that through every single term. And the advantage is that when you do that, it's going to clear your fractions. So the first one, 4 times 1 is 4 divided by 4. So then that's just going to become 1y. 4 times 7 is 28. The 4s are going to cancel here, so it's just going to be a 3y. And then you'll minus 3 times 4 is minus 12. So I'm just going to kind of work through these, and I want you to stop me if you have questions, if I lose you anywhere along the way. Okay. So the advantage of giving the LCD all the way through is that it just knocks out all your fractions, and then you're just left with an equation that has all whole values, and those ones we know how to solve pretty well. At this point then, so I might bring my y terms to the right-hand side by taking away y on both sides. So then you'd be left with 28 equals 2y, and then you could add 12 to both sides. So it looks like, 40 equals 2y, and your last step would be division by 2. So you'd get not 40 times 2, 40 divided by 2, which is 20 equal to y. Yeah? What do you think? Questions on that one? Did I lose you anywhere? No one's saying yes, but some of you look confused. It's okay? Okay. All right. All right. So, yeah, sometimes it's hard to read faces because some people really wear their emotions on their face and others don't. So, it's just your math. Yeah, that's just the face I'm making when we do math. Okay, so the next one was 2.4w minus 100 equals 0.8w plus 28. Decimal problems you can solve with the decimal terms. It's really not that inconvenient because most of us work pretty well with decimals. So for example, if it were me, I would probably just leave the decimals and I would probably go, minus 0.8w from both sides. That would get all my w's over on the left hand side. So then you can pull out your calculator for any help you need on decimals. That's the nice thing. So 2.4 minus 0.8, I think that just leaves you with 1.6, right? Someone might want to check that for me, but I'm pretty sure that's right. Okay. Then we can send our w to the other side by adding 100 to both sides. So we'd just be left with 1.6w. 28 plus 100 is just 128, and then you just divide both sides by 1.6. And again, since we have our calculators, it's not that difficult to do. You just put 128 divided by 1.6 in your calculator, and that comes out to be what? Is it 80? 80, 80, 80? I'm getting 80s all around, so I like that. Okay. So working with the decimals, not that bad really. It's a lot easier than fractions. You could clear the decimals out if you really want to. I'll just do it in red. I'll just do it in pencil over here. Okay, is that like you could just move all the decimal places over 1 point to clear the decimals, so then you'd end up with 24w minus, this would become 1,000, and then it would be 8w plus, and this would become 280. And so what happens though is, so the numbers become whole, but they also become bigger. So it just depends on what you prefer. Because to finish this, the steps are going to look the same. Like you'd subtract 8w, and you subtract 8w. That's basically just like the subtracting 0.8 on both sides. So this would become 16w minus 1,000 equals 280. Then you'd add 1,000. So basically you're doing the exact same processes, just with things that are 10 times bigger. So this will become 1,280. Oops. And then you divide both sides by 16, and then you'll get the same answer. So either way works. It just depends on whether or not you like working with decimals or whether or not you would like to convert them to whole numbers. Okay. Anyone have a preference? I have a preference for the decimals. Okay. Questions on either of those? Not too bad, hopefully. All right. Let's see. Let's go to the next one. So then we got this one. This one can be approached a lot of ways. So there's really no right or I'll go back to my blue. There's really no right or wrong way to approach this. So for someone who took a shot at this, what was your first? What was your choice here? How did you approach this?
I didn't take a shot.
Okay. Anybody take a shot at this one? We have to do something. So
Is it like multiply by 2 and then divide by 3?
yeah. So one thing to think about is you could think of this is multiply by 2 divide by 3, right? On the left hand side, that's what 2/3 means. So you could are you talking about just distribute that 2/3 through?
Yeah.
Sure, you could. So you could just distribute the 2/3 through. This is option number 1. There's a lot of ways to solve this thing, okay? But this is option number 1. You could just distribute that through. Now, you have to be comfortable. You got to remember how to multiply whole numbers times fractions, and that's what you were just saying. How do you multiply 9 times 2/3? It's 9 times 2 is 18. 18 divided by 3 is 6. So that'll actually become 6c. And then what's going to happen when you do 2/3 times 3? Yeah, the 3's are just going to cancel out. You're going to be left with 2. Right? Now, we're not multiplying both sides by 2/3 here because the 2/3 was only on the left-hand side. So that's one way you can solve this problem is you just send the fractions through and then deal with whatever comes out. That's not a bad way to do it. And then this one you could finish, right? Pretty easily, because we would just do what? So, add 2 to both sides, so it'd become 6c equals 24. Divide both sides by 6. C is 4. All right, what questions do you have about that? Okay. Now, there's another way you could solve this. Some people look at this. Anybody else see another way to look at this equation or another way that you might think to start it? Besides just straight distributing the fraction through? So one way to look at it is to think of this as like 2, there's dividing by 3 on the left-hand side. So one way to think of it is like we could get rid of that division by doing what to both sides? So this is divide by 3, so we could just, what? Multiply by 3 on both sides to get rid of the denominator. Because, I'm thinking of it back when we saw equations that, if it was x over 3 equals 22, what would you do? Yeah, if you saw this equation, x over 3 equals 22, how would you get that 3 over the other side? You multiply both sides by 3, right? You cross multiply it over, right? So that, some people look at this and think the same thing. They say, oh, a 3's on bottom, so I'll just multiply both sides by 3. So the 3's will cancel on that side, and then this will become 66. Or another way to think of that is like multiplying everything by the least common denominator, right? That's what we're really doing here. There's a denominator of 3 right here, and I know that in equations, if I want to knock out denominators, I can just multiply both sides by the LCD. And that's what I did here. So the 3 cancels out the 3 there, no more fractions, and then that just multiply by 3. Then this is all a whole number equation, so we could finish this one off, and now when we do our distribution, you know, they're all whole numbers. So then we could add 6, it'd be 18c equals 72, divide both sides by 18, and you can plug it in your calculator, but I would be willing to bet that 72 divided by 18 is 4. So the other way to think of it is, oh, there's a fraction here. I'm just going to give everything the LCD and then make it work. It'll knock that out. Okay. But distributing the fractions through in the first example was not a problem. Now, there's actually a third way you can even do this. Because the other way to think is, you know, everything here was, once we multiplied the 3 out, then there was also like this 2 times this quantity. So everything just ends up as a multiple of 2, but we could have just divided the 2 out to begin with. And so when you see a fraction, one of the strategies I showed you before, like if you see, how would you solve that equation? 2/3 x equals 5. I think there was one on your last exam. We did stuff like this. If you see 2/3 times x equals 5, how do you get rid of 2/3? You multiply it by the reciprocal, 3/2. So we could do that here actually. So we could just say, well, I'm going to give this whole side a 3/2, which means I have to give this whole side a 3/2. So then the fractions will be completely gone on the left-hand side, and you'll have 9c minus 3. And on the right-hand side, you can simplify this because 22 times 3 is 66 divided by 2 is, that's just going to come out to be 33. Then, how do you solve that one? Well, you add 3 to both sides, and you'll get 9c equals 36. Divide 36 by 9, and you'll get 4. So, which one is easiest? I think personally, I'm more prone to do things like the third one, but this one's also pretty straightforward, I think, too. I've just seen people do it this way before, so I show you that one. But I think probably the first one or the third one are the most common ones I'll see done. But yeah, you can never go wrong. If you just distribute, it's not like you can go wrong doing it that way. It's just what you might end up with is you might end up with more fractions, and then you'll have to deal with those in the next step. But that's not necessarily a problem as long as you're kind of comfortable with working with fractions. So. Okay, any questions on any of those? All right. So let's move on. The next one, not as complicated. We just need to do what to solve this next equation? What should we do? I want to get rid of those parentheses, so I need to distribute the negative through, right? It's like a -1. So this becomes 15 minus 3r minus 8 equals 28. Once you've gotten rid of all your parentheses, the next step should always be to collect your like terms. So 15 minus 8 is 7. Okay. And then now what should we do? Trying to get r by itself. So we should. Well, we can't divide yet because we still have a 7 over here. Yeah, so we need to subtract that 7 over here, right? And then so it would be negative 3r. 28 minus 7 is 21. And then you can finally divide that negative 3 out on both sides. So 21 divided by 3 is 7, but a positive divided by a negative. Yeah. Questions on this one? Where did I lose you? Did I lose you anywhere? All good? Okay. Then we've got the next one. We got 5/8 b plus 1/2 equals negative 3/4. Yeah? Okay, well, this one has a whole bunch of fractions. So how do we knock out all these fractions? What do we need to give it? What does it need? The least common denominator. You have multiple of all the denominators. So what do we got here? We got 8, a 2, and a 4. What's the LCD there? 8. So then I'm going to give everything, I'll give everything on this side an 8. I'll multiply this side by 8. Boom, boom. Over here, what's going to happen on that term right there? The 8s are basically going to cancel, right? Or you can think of it as 8 times 5 is 40 divided by 8 gets you back to 5. So this will be 5b. What is 8 times 1/2? Well, 8 times 1 is 8. Divided by 2 is 4. And then here, you got 8 times 3 is 24. 24 divided by 4 is 6, but it's negative. Okay. So now you've got it into a whole number equation. This one's not too hard to solve. How do we solve for b? Well, first we got to do what? Take away that 4 from both sides. So then minus 6 minus 4 is negative 10. And then get b by dividing both sides by b. So then it looks like b is going to be negative 2. What do you say? Yeah? Stop making that question. But the next one is really similar. Just a whole bunch of fractions. What's the LCD on this one? Everything needs a 12, right? Because it goes all the way up to 12. So everything here gets a 12. Everything there gets a 12. So 12 times 1 is 12 divided by 2. This becomes 6a. 12 times 1 is 12 divided by 4 is 3. 12 times 1 is 12 divided by 6 is 2, and that's an a term. And then 12 divided by 12, all that's going to be left is a 1. All right, so now we got like variable terms on one side, on both sides, numbers on the other, so we need to collect our variable terms. I like to keep mine positive, so I would take away 2a from both sides. 6a minus 2a, that would leave us with 4a's. And everything else stays the same. Now I want to send my numbers to the other side, so I'll add 3 to both sides. And then you get 4a equals 4. Divide by 4 to finish it, and then it looks like the answer is just positive 1. Questions? What questions do you have on any of those? Easy? Hard? Medium? How are you feeling? Are you guys feeling good about solving equations or not? I need to know. I really kind of want to know. Is it bad or good? Nobody is willing to speak up? Nobody has any opinion on it? Just ambivalent?
It's gonna take time.
Yeah, it takes a lot of practice. These ones especially, these are the ones that you need to be getting in there on Canvas and looking at the suggested practice problems and really working through some of those suggested practice problems, because it's not hard, it just takes a lot of practice to really just get the steps ingrained, Okay. Did I lose you in any of these steps? Were there any numbers on there where you're just like, I don't even understand where that number came from?
Watching you do it, usually it all makes sense.
Yeah, true. Yeah. Right, yeah, and that's where the practice comes in, yeah. Yeah, and it's easy to watch somebody else do it, because the great thing about it is that if you don't break any rules, you always get the right answer. So it looks really easy if someone who doesn't break the rules does it, because it makes sense, right? It's logical. It's mathematically logical. But the hard part is working through it without breaking the rules. And that's something that only comes from practice. Okay. All right, let's do some more of these. This is going to take us a little bit longer to get through today. So we've got a decimal one, but again, I think the decimal ones are probably the easier ones for most people. So I would probably you could just even leave this as decimals if you wanted. So like we could bring that 0.6x over here, and that would be 0.1x. And then we'd have a 2.4 there. And then we could subtract our 0.4 from both sides to get our x term alone on the left-hand side. So that would be 2.0. And then our last step would be divide by 0.1 on both sides. So we get x. And if you can plug this in your calculator, you should be able to get 20 for this one as a solution. Okay. Now, you have the option, though. You have the option of just moving all those decimal places over one value and turning this into a whole number problem, because this would just become 7x plus 4 equals 6x plus 24. And then when you bring your x term over, then this will just be x plus 4 equals 24. And then when you subtract your 4 to that side, you'll just get the same answer. Okay. So you can do it either way with decimals. You can solve them with the decimals, no problem. You'll probably end up dividing in the end, but that's okay because your calculator can do division of decimals. Or you can clear the decimals and just solve them with whole numbers. Whichever one works for you. Okay. All right, now, the next one is also a little bit complicated. And it's complicated in the sense that it could be solved similarly. There's multiple ways to solve this, similar to how we saw this last time. So what could you do if you open up your exam? This is a problem that's staring at you. What could you do? Yeah, one option is you could just see this as 1 over 5 and then multiply both sides by 5 right away. Okay, that's a pretty good strategy because what happens is it's going to cancel out the 5s on that side, and all you're left with is just 1 times that, and on the other side you have 5. So that'll actually work pretty well to do it that way. Okay. So then this one's pretty straightforward from this point because you just add 10 to both sides, and you'd have 15 equals 15y, divide by 15, divide by 15, and you'd get, y equals 1. Okay, so that's a totally reasonable way. If you recognize that as 1/5, multiply by 5 to cancel it out, finish it from there, no problem. But some people, when they see parentheses, they just automatically want to distribute it. And that's okay, actually. It'll work. So if you go 1/5 times 15, well, 15 times 1 is 15 divided by 5. This would be 3y. And 1/5 times 10, well, 10 times 1 is 10 divided by 5. This would become minus 2. And then you could just add, 2 to both sides. So you get 3 equals 3y. And then you divide both sides by 3. And you'll get the same answer. Yeah, so it's okay either way. So try to recognize that situation so you can just multiply the fraction out right away. Recognize it as like one where you get the LCD. But if not, anytime you see a number next to parentheses, just distribute it and then see what happens and work your way from there. You got to do something, so you might as well try whatever you know how to do. Okay. Any questions on that one? Oh, where the numbers come from, anything like that? Great. All right. Then just a little. Again, we got some decimal stuff going on here. So 1.56 equals 0.58x minus 0.64. If you wanted to turn this one into whole numbers, it's pretty easy to do it. Just move all your decimal places over 2. Right, so you get what? 48x plus 156 equals 58x minus 64. And then it's just solving it with whole numbers. So we would want to bring all our x terms to both sides. I would probably bring them over here so they stay positive. So you'd be left with like 156 equals 10x minus 64. And then you can send your 64 over to the other side. And then what does that come out to be? If you add those, 156 plus 64, 220 equals 10x. And then you can divide both sides by 10 so that you would get 22 for your solution there.
Wait, why for this one did you move it 2 spots for like the one from earlier we only moved it one?
Yeah, so that's a good question.
Is it just like you can move it no matter what, but you, like, you have to do it the same amount for everything?
Exactly.
Or-
So you just have to do it the same amount on all the terms, but you don't want to do it any more than you have to. So in the last example, there was only one place value behind the decimal, so we only needed to go 1, no need to go 2. But in this place, 1 wouldn't get us far enough because we still have decimals, so we go 1 more. You just got to make sure you're consistent across all your terms.
Okay.
Yeah. Yep, that's a good question. All right. The last one has a fraction on both sides. So what do we do about that? Yeah, if there's multiple fractions in an equation, what do? We just give everything the least common denominator, right? So what's the least common denominator between 1/5 and 1/2? It's 10, right? So I'm going to give this side a 10, and actually I don't even really need the parentheses there. Just write it as times. So I'll multiply this side by 10, and I'll multiply this side by 10. And then what's going to happen right here? So what is 10 times 1/5? It's just 2, because 10 times 1 is 10 divided by 5. 10 divided by 5 is 2. So this is just going to become a 2 outside the q plus 3. And then over here, well, what's 10 times 1/2? 5. Yeah. So you multiply by that, and then now all of your fractions are gone. But you're not done yet, because what should we do now? Yeah, we got to get rid of our parentheses, so we should use the distributive rule. So over here you get 2q plus 6, and over here you get 5q minus 15. All right. And now we just got to collect our q terms on one side. I'd probably send them to the right-hand side, because that'll keep it positive. So you have 6 equals 3q minus 15. Then you can add 15 to both sides. So you get 21 equals 3q. Divide by 3. Divide by 3. It looks like the answer is 7. So this is especially out of 8.3 and 8.4. So if you're looking for more places to get practice with equations, I'll show you if you haven't looked at it recently. So if you're in Canvas and you're in the modules, that's where you can find all my suggested practice problems. So in the chapter 8 module, if you go down here, it's going to be right here in the suggested practice problems. And if you pull those out, 8.3 and 8.4, that's going to be where you're going to get more examples of all these equations. 8.3 is mostly like solving the equations and getting more complicated. 8.4 is when you start throwing in fractions and decimals. So if you want more basic practice on just equations in general, go there. But if you want more practice with the fractions and decimals, you want to be in 8.4. I'll give you more stuff. Okay? And those are in the modules again. So you can always find those. Hopefully you've been kind of vaguely paying attention to those, because those are the problems I would be kind of expecting that you're looking at in order to prepare for like the quizzes. Now, one thing I want to give you today is So that's where you can get the equations, but within those sections, there's practice with just solving straight equations like we've done for the past like couple days. But the goal is not just to solve like equations that have no applications, because that's kind of dumb. And so what they have is they also have a lot of applications of these. So I have a couple examples I want you to take a look at. They do a pretty good job in chapter 8 of setting up the helping you set up the equations and then letting you solve them. And then chapter 9, though, is when we're going to get into the point where we're going to have to restructure the equations ourselves. Yeah, we're going to start chapter 9 tomorrow. Not really.
I'm very
I was going to see if you have